Welcome everyone, and good morning. For those of you, it's morning time. Welcome to today's webinar hosted by IDERA Studio and IDERA. The topic is Back to Basics, Data Modeling in 2024 and Beyond. I'm Tim Ortiz, the Product Marketing Manager for IDERA Studio. Our hosts today are Kent Graziano, the Data Warrior, and Jamie Knowles, Senior Product Manager for IDERA Studio. Today will be a vibrant and informative conversation about enterprise data modeling in the current context and, of course, the future. So please submit questions through the GoToWebinar question panel for our two experts, as we will have a 15-minute Q&A at the end of our presentation. Without further delay, Jamie, would you please take it away?
Great, thanks, Tim. So, hello, everybody. Yes, I'm Jamie. I'm the product manager for IDERA Studio. I've been working in data modeling, working in the field, doing data modeling and working on data modeling tools for 25 years. Kent, I think you know a bit about data too. Do you want to
just a little bit, yeah. I've been at it for multiple decades. I was just thinking about that. I think I probably got introduced to data modeling in 1988 or 89.
So that's quite recently then, yeah. So data modeling itself has been around for a long, long time. So today we're going to talk about why does anyone want to do data modeling. I'm going to give you a quick intro as to what it is. And it's really about the benefits and why wouldn't you do data modeling. So, okay, so Ted Card and Chris Dake came up with relational theory back in the late 60s, and principles I think have held true ever since. We've been creating nicely structured data models of the information of the organization ever since, and using those models to design and document data assets. So I guess we ought to introduce everybody what is a data model at its basic level. So we've got a bit of a slide here. Shall I sort of kick things off, Kent? So
sure, go ahead.
So most data lives in databases. So there are similar sort of things that work with files, but for databases, you can create a database using code. Great, and there's a little example there, some scary looking code. Now, the challenge is we want to go from a whole series of business requirements all the way to a live database. So there's going to be quite a few people involved. We want sort of business stakeholders to get involved in the process. So working with code is quite problematic. There are some really cool databases around with their own little sort of consoles that allow you to see the sort of tables and structures in your database, but you really want to be able to have a nice sort of easy to understand conversation with your stakeholders. So over on the left-hand side, this is where data models kicked in. Data models are generally graphical and human readable. So there's two types of data model. We've got logical models, which are independent of the technology, and they are in business language. So we draw nice pictures. So in this case here, we've got a customer, and we've got a type of customer, which is a B2C customer, and we identify a customer using its customer identifier, and it's got a credit rating score, and our B2C customer has a relationship with a thing called an order. Great. So that's pretty easy to understand. Any business person should be able to look at that, and we can have a good conversation. So when we're taking requirements on a data assets, we can draw a picture of it and have a good conversation and agree the requirements for that. And then generally, we're then got to get from that to that code that we're looking at on the right-hand side. So this is where the physical data model comes in, which again is based around a picture, but it's in this case dependent on the technology, and various technologies have rules like naming conventions. You can't have spaces in the names and a certain number of characters and different data types, and there's all sorts of features of the database. So we create a physical model that's aligned with the database, and again human readable, but it's in technical language. And data modeling tools are available that will convert from a logical model to a physical model, and then from the physical model then generate the code, and then you can deploy the code to the database. So that's the basics of data modeling. Ken, have you got anything to add to that?
Yeah, it's unfortunately today I think a lot of people end up starting at the database level, where I think you and I we start at usually at the conceptual and logical level and talking to the business. And started, that's all the development I did over the last couple of decades. We always started with a diagram and working with the business and getting business definitions, And so it's not just the names, right, as you see on the diagram, but behind that, there's a lot of metadata, like what do we mean when we say customer? I worked at HP for a number of years working on a supply chain model. And in the end, it turned out there was like 20 different definitions of product, at least 20, right? And so there's a lot more to it, and you can learn a lot by working with the business in trying to model these things. And that really is important if you're going to go build a database and you want to collect the right kind of data to solve business problems. You have to make sure you actually understand it. And I think, you know, data models are really one of the best ways, of course, in my mind, of doing that, is actually doing that and doing it collaboratively with the business, which means starting at the left side of that diagram with the logical data model, as opposed to starting with a database and trying to have the business people understanding the code, and, you know, SQL code for creating tables. That's just not going to cut it. We really need to start, you know, before we ever get to the technology, is what is it we're really interested in learning about? What is it we need as a business to keep track of? What do we need to run the business? But then also, how do we do analytics about how we're running the business? All these things come into play, but you really have to understand from the get-go what the business means when it says customer and product and order. And, you know, in healthcare, what is a patient? You know, what is a provider? You know, what is a hospital? What's the difference between a hospital and a clinic? All sorts of questions that you need to ask that have nothing to do with the technology.
Yeah, I'd agree. I was thinking of a project that I worked on where we're trying to design a HR system. We keep talking about shift pattern. Great, so the system's got to hold shift patterns. And it was quite a long way through the project that we realized there's 6 different types of shift that you can have. And each one has got different characteristics. And sort of those sort of nuances of the information is sort of best sort of understood through. I think something you mentioned there is sort of documentation as well. So something you won't get if you just sort of go straight to the database is sort of a really easy to understand documentation of what you've got. What does it all mean? So the developers come along and create it. At that point, they all understand it, and then they move on. So then how does the rest of us then, what are they faced with to understand what's there? So having a model of it all that's got all that business metadata that you were saying there, Kent, I think is absolutely vital.
Yes.
Cool. So yeah, so there's 2 use cases here. One is designing a data asset, starting from left to right. But then there's the other side where you've already got a database. Perhaps you just bought a COTS package and we want to integrate to it. So we might actually go the other direction. We can reverse from the database through the code, get the tool to create a nice physical model of it. And then you've got to start working things out. Okay, I've got a table here called cust and C_RTNG. What does that mean? So then we start documenting it, create the logical model, add the business metadata, etc. And then we've got a picture of the data. We can then start thinking about how do we interoperate with this database.
Exactly.
Cool. All right, so that's the basics of a data model. And this is really sort of just dealing with one individual data asset. Now, I think most organizations will have a large number of data assets. Kent, I don't know what sort of numbers you've seen, but I mean, typical decent sized business might have many hundreds of business systems. Each business system has its own database. Things can get busy pretty quickly.
Yeah, and then there's certainly you know, even conflicts between those businesses and how they define things. You know, would it not only what they call it, but what does that mean, right? In all those different systems, and depending how they were developed, and over time, you know, we go back some of the old systems, the naming stanzas were very arcane, and the people who designed it are long gone and really don't know, you know, what these things were meant to be. You know, short abbreviations, just like, you know, what you had there. You know, the classic one that we always talk about is, of course, SAP. The tables in SAP in the early days were short, very short, you know, 8 to 10 characters, and they were not only abbreviated, they were in German. So if you didn't speak German, you would have no idea what the contents was simply by looking at table and column names.
And then it's just sheer scale. I think SAP's got 80,000 tables in it. So, I mean, how do you start understanding all of that and visualizing sort of what's related to what and how it's all connected? It's nightmarish.
It's certainly a challenge.
Cool. So I guess the next part of the conversation then is sort of, so we're understanding an individual data assets, but we really want to start understanding all of our data assets. And this is where enterprise data models come in. So I'm just going to hop to the next slide. So some of you might have seen this before. So the notion of an enterprise data model. So down at the bottom, we've just been talking about a data model for a particular application. We've got an application logical model and an application physical model. Great. We've got lots of these. As we said, we might have 500 or 600 of them. The idea is okay, if we're designing systems, and with ER Studio, we've got tons and tons of customers that have been using ER Studio for 30 years or so, where they're building a lot of applications in-house. Okay, so we want to be able to quickly build those applications. So can we have some sort of standardized models that will sort of kickstart the development of those applications and get things going quickly at reduced risk? We also want the applications to communicate to each other, interoperate. So sort of understanding, okay, this system's got the notion of customer, this system's got the notion of customer. How do we get them to talk? How do we identify an instance of a customer within them? So having standardized views is really important. So the enterprise logical model here, or enterprise model, it's kind of got 3 layers. So starting at the bottom, we might have our standard definitions of things like customer and realize, whoa, we've got lots of different types of customer, and each different type has got different characteristics. But here's a standard definition of customer, standard properties that we assign to a customer. How do we identify a customer? So that's our sort of enterprise logical model, full of standard definitions. Now, when we get to talking about our data, things can get busy pretty quickly. So we have these higher levels of abstraction. And when you're talking to sort of business people about the information of the organization, we want a sort of a good, well understood, well agreed list of concepts. So most organizations will have a conceptual data model with 100 to 300 sort of business concepts in there. And then we can arrange those business concepts into different subject areas, so maybe 12 to 20 business subjects. So we've now got a nice sort of clean model of the information of the organization. We've got a simple model at the top where we can work out what's what, and then drill down and get more detail as we go down, and then eventually tie it to our application models. And I mean, Ken, is there anything you want to add to that so far?
Yeah, I think one of the things that occurred to me is we've been talking a lot about data mesh, and in data mesh terms, they talk about domain teams, and that really is the subject area at the peak, right? Any organization has these subject areas, and that was what we used to call it in the data mesh world. They call them domains, and you need to be able to interrelate all of those to get your full enterprise model. I think one of the key points they make in the data mesh approach, which I think is always worth reinforcing, is to make sure that there is that communication and there's that overarching vision of the enterprise, so that each domain does not become a silo. Just because they're different subject areas and each of those subject areas or domains may be, I'll say, responsible or the logical owner of certain sets of data, they shouldn't be treated independently or developed independently. At some point, you need to put them together, and that's really, you get your subject areas and domains and start building out your conceptual data model. And the conceptual data model includes relationships between these significant business entities. And that's where we're really, when we're talking about an enterprise data model, we're talking about looking at the interrelationships of the data across departments, across divisions, across subsidiaries, whatever it is, whether you're a large global organization or you're just a small mid-sized business. You still have, you probably have accounting, you probably have finance, you probably have customer service, you may have product development, or you just might have sales. And there's relationships between all of those areas that we need to understand if we're really going to understand, the data assets of our organization.
Yep, that makes sense. So I was going to come on to data mesh later on, but for sort of the traditional approaches to application design, application interoperability, this sort of stuff is absolutely vital. Being able to understand what is the information for each application, to be able to design new applications, for those applications to be able to communicate to one another. I suppose there's also sort of interoperability outside of the organization. If you're partnering with other companies, you're going to be exchanging data with them. There's going to be sort of lines of communication, and you need to be able to define what the data is in those lines of communication.
Yeah, and today we've got, we now have data marketplaces that we didn't used to have, right? And so there is it's much easier to get access to third-party data that's external to your organization, but still data and information that may be vital and beneficial to running your organization. So it helps to have those ideas as well in your conceptual model to know, here's some other data that we don't actually collect ourselves, but if we can interrelate it to data we already have to our customers, maybe it's extended demographics about our customers, and we don't collect those ourselves, but there are other organizations that do. One of the funnest ones I ran into at when I was at Snowflake, when they started the Snowflake marketplace, was an organization that collects foot traffic. So if you're a retailer and you're looking at opening a storefront in a shopping center somewhere, or one of these outdoor mall type areas, was very important to see on a daily, weekly, monthly, seasonal basis how much foot traffic is going through there. They were actually able to, they were tracking, probably via GIS, how many people were coming in, because of course we're all carrying around phones today, and each of our phones are little GIS, geolocation units, and so you can see these things, and you can see the flow and how many people are going through this area on any given time period, and that may be something that you want to know before you invest a couple $1 million in opening up a store in a particular location. Or maybe that's part of your analysis, answering the question, well, we want to expand, where should we expand within this geographic region, and to be able to look at that. But that was all data that as a retailer, you wouldn't have the broader set of data, but there are providers now that do that. And so that's something that then would be, I'll say, attached to your conceptual model, is this type of data that is outside of our organization, but still related to and usable by our organization, along with the data that we collect ourselves.
Nice. Yep. So we've been talking about sort of the world of applications primarily so far. So from designing applications, then great. Having these sort of standardized enterprise models is going to give me lots of benefits. It's going to kickstart those projects, reduce the risk, reduce the time, ensure consistency. If I've got to interoperate within my business, this is really going to help. If I'm going to interoperate outside of my business to others, having a clear understanding of what our data is and how other people's data will fit into it will have benefits. I mean, and we've seen this with sort of companies in groups, conglomerates. If they've got different sort of business divisions that need to interoperate, having some sort of standard notion of information across those different divisions is incredibly important to interoperate. So, and with applications, we're seeing a lot of companies saying, hey, we're not designing and building our own applications now. We're buying COTS package, or we're moving to the cloud. We've got a whole pile of cloud systems. Great. But interoperability is still really important for that. So standardized information models. I remember working with a bank, a large bank in the US a few years ago, and they're saying, well, our databases are running on systems that are probably 30, 40 years old. The data didn't really change. So, but the interoperability between those systems and externals is more important than anything else. So standardized models is really important. Okay, so that's applications. Let's talk about analytics, which is more your area than mine, Kent. So yeah, if I want to build an analytics program in an organization, mean, do I really need a data model? Why can't I just sort of focus on the warehouse in isolation? Maybe I could even use a data modeling tool and sort of, rather than going to code, create just a isolated model of that warehouse. What benefits would having an enterprise approach give me?
Well, what we were just talking about is the whole interoperability and the relationships between the data. I mean, building a data warehouse, of course, in my mind, we should be building it incrementally, but building it from a data model that is well documented and well understood. If you don't have an enterprise model, and I work with many organizations that jumped into data warehousing and really had no understanding of their enterprise model, and so the first step ended up being, well, if you want to do analytics on this type of data, where does that data come from? How is it related to other data in your organization? And we always ended up needing to build that model, and starting off with more of a logical data model, usually normalized, to understand, as we've been talking about, what are the meanings of these things. And we're saying, well, we've got 15 source systems that we want to. We're pretty sure the data we need is in those 15 source systems. We need to bring them together into a data warehouse so we can do cross-functional analytics. Great, but do you know how those independent application systems, how are they related? How's the data in them related? Because part of data warehousing is integrating the enterprise data. I mean, that was kind of the goal when Bill Inman first laid out the concepts of data warehousing. Is one of the terms in his definition is integrated, right? We're not going to bring in, if we've got customer records in 15 different systems, we're not going to just bring those all in and guess as to whether or not any of them represent the same customer. We have to figure out ahead of time, what are the relationships? How do we identify customers? And that, again, back to what we originally said, the definition, what does it mean to the organization? How do we define a customer? And then looking at those 15 systems and saying, okay, do we have customers in each of these systems? Do the definitions align? How would we bring all that data together? And having a data model, again, of the source system, so this is just the application logical models to begin with, having that is very beneficial. But then if you're going to build, and the way I term it, data warehousing should be source system agnostic, because you get all kinds of new source systems. And of course, today, with off-the-shelf packages and cloud-based applications, people are changing the source and where they store their operational data all the time. So you want to make sure that when you're building your data warehouse, that it is independent of the source systems. Now, data lakes, people jumped into this whole data lake thing. It's like, oh, we're just going to take all the raw data, we're going to throw it over to a data lake, and we're going to let the data scientists pull it all together and answer all the questions. Well, as many people have heard, data scientists, on average are going 60 to 80% of their time trying to figure out how to integrate the data. Well, why is that? It's because there's no data model, because nobody's bothered to build a data model. And part of it is this fear that continues and has, my entire career, that it's going to take too long. This, in the old days, back a ways, when I first started, people would do enterprise data modeling projects, and they would run literally for years. And you would end up with a logical data model, the standardized ones that you have there in the bottom of your pyramid, and then they would hand that over to the database team and the DBAs, and they go, we have no idea what we can do with this. And then they try to build the database, and it doesn't quite line up, and there's just a lot of churn and costs a lot, and it doesn't really work out. So we have to learn how to build these things incrementally as well, a little at a time, based on the business priorities. An application system is not a one and done in most cases. Data warehousing absolutely is not. Trying to do analytics, you need to figure out what are the business problems we want to solve with analytics. And this is a conversation with the business, just like we were saying with the conceptual models. And so you've got to have that conceptual model to start with. Is what are the subject areas? What are the problem areas that we're trying to solve? And if you have an enterprise data model, then you can start pulling that piece out and start looking at that. And so you have some documentation and you have some understanding.
Ask next is the sort of we've covered the understanding the source data. So I've got my 500 different systems out there, business systems, each with its own pool of data. I've got things like customer information scattered across a large number of those, and I've got to try and reconcile. Okay, this one's talking about customer in this way. This one's talking about something that's also customer. Okay, how can I reconcile them into sort of one integrated data set? So I guess that's the first part of the problem, is understanding what data have you got, the meaning and nature of that data.
Yeah, and whether it's a data scientist or a data engineer, analytics developer, if we can provide them with at least a logical data model, that's their blueprint, right? To answer those questions of, well, how do I integrate the data from these 15 different systems? You have to have a foundational, standardized understanding of the meaning of that data, so you can start putting it together. Again, back to the data lake / data swamp scenarios that we've had over the last decade of, great, I've got all this data out there, and all the column names are different. They're abbreviated. I don't know from one file, and if we're dealing with, we were dealing with Hadoop and we're dealing with files, from one file to another, how are these things interrelated? If you have a data model, at least as a blueprint, that helps you with the data profiling and the understanding. If you know that this set of files came from this source system and this set of tables came from that source system, you have a better chance of seeing how do these things relate to each other, and how can we bring them together coherently with high level of confidence and high level of quality into a data warehouse, so that we can be driving data-driven decisions and be confident of the inputs.
Yes, so I suppose if you've got a table of customer information, you want to know that all these customers here are sort of similar. I don't want to be mixing up different types of customer in this sort of set of customers. Great, this is my B2C customer list, beautiful. And then I want to know that each customer in there has got one record. We don't have duplicates or problems with it. Cool, okay. So just the same sort of problem we have with sort of interoperability of applications we've got with our data warehouse. The next thing you were touching on is sort of, okay, I want to be able to satisfy the requirements for the warehouse. So how would, sort of without data models, how would you really sort of capture the requirements for a data warehouse?
That's the mystery to me. It's like, again, where do you have those conversations? Writing it all down and having, today we talk about having data catalogs. Okay, great. A data catalog is a great way to inventory the existing data assets, but that still doesn't give you the interoperability. It doesn't give you the relationships necessarily. You may get a lot of good business definitions, but at some point you still have to reconcile these things. Again, if you're looking at it from a source perspective, from an application perspective of where all this data is, different modules, all of that, you still have to need this a good data model to tell you how to put them together. And I've seen a lot of organizations that really, the developers, now mostly we call them data engineers, and they end up with the bulk of the work is they get told to go, they got to go figure out on their own through data profiling, through extensive, because we're talking about now terabytes of data in many cases, is trying to profile the data to figure out how it's interrelated, where if everybody took a step back and did the logical data model up front, and even it's just a portion of it, again, we want to have good scope control is still always a challenge, even with data modeling. What problem were we trying to solve? Well, let's just look at this piece of the conceptual model and drill down on that to figure out how these things are related, so that we can build, again, an analytic system, whether it's star schemas, their normal form, or data vault. We have to answer the same questions. How are these things related, so that we can integrate the multiple sources into our analytics platform?
So I suppose you've got options. You've got I'm going to build a warehouse by just taking a whole bunch of source systems that I think has got good data in. I'm just going to load all that data into the warehouse and then say, right, we've built it, they will come. Just have at this data. So that's one approach. I guess the second approach that you were just talking about was, okay, I've got a whole pile of data engineers and analysts out there that have got a particular business problem from someone. They go and source their own data. They create their own regions in the warehouse, their own little micro design, and solve that business problem. And then we've got X hundred of those engineers all working in the warehouse at the same time. What's wrong with those two approaches?
Well, then we end up with silos of data. So each little project, each little problem is potentially solving the same issues over and over again. And in the early days, I saw people doing that. People were like, "Oh, we're going to do departmental data marts," and what that ended up meaning is that they were solving for that department, the questions that they had. But if there was overlap, and it might all be coming from the same source system, right? You've got, say, you're running SAP and you're trying to pull customer information, and each department is independently pulling customer information from the same source. And this is like one of the worst case scenarios, because based on their understanding of the problem, they may actually pull and transform the same data in different ways. And so the classic example that we always throw out there is the CEO says, "How many customers do I have?" And finance says 300, and accounts receivable says 250, and sales says 5,000. And okay, how many customers do I really have? No idea, because each of them, they built their own siloed data mart without looking across the organization, without reference to an enterprise data model. And so you end up with very different answers for the same question. And that, of course, then leads to, really massive risk in making decisions based on this data. But immediately you have questions about data quality, right? And the folks who are using the systems, when they find out that the answers are different from these different marts, well, then they lose confidence in the entire data warehouse. How can this be correct? How can this be correct? So I had that in one of my systems, where the first time we ran some of the reports, they said, well, that's clearly not right. That's not how many employees we have. But we were able to trace it through all the way back to the source system and say, yes, that is how many employees we have. And they say, well, that's not right, because we're paying more people. Well, turned out there was a pile of folders on somebody's desk that had not yet been input because someone was on vacation, and they still had to pay the people, but they hadn't actually entered it into the system they had told us was the source of truth for the number of employees. And so without those conversations about what do we mean, where is it defined, where is it entered, what are the business processes, you can end up with these very disparate answers, which just, again, lowers the confidence in what you're doing and the results that are coming out. A data model helps solve those problems because, again, as you said earlier, it's a communication tool, and you can have conversations before you start engineering anything. And then once you've done the engineering, you can use that as a point of reference for quality. Is did what we build represent the rules that we were told? That's your point of reference. So that's one of the many places you can check. And did we write tests to support the model? We can use the model to develop the quality assurance tests that we run in the data warehouse to see, does every customer have an address? If the model says every customer must have an address, well, when we've loaded the data, we can go run a test and say, does every customer have at least one address? Is every address in our system associated with at least one customer? And you can get all that sort of thing from having a good data model.
Makes sense. So before I sort of go on to the next point, just want to let everybody know, if you've got any questions on anything that we're talking about, there's a questions box in GoToWebinar that you can just send us questions and we'll try and answer them as we go along. customers are talking about the medallion approach to data warehouses. Tell us about what is that and how does that fit in with what we've been talking about?
Yeah, it's been an interesting conversation over the last couple of weeks. It's surfaced a lot more. This is a pattern that I think was started by Databricks about its bronze, silver, gold levels. But really, fundamentally, this is something that's been around in data warehousing since the 90s. Bill Inman called it the corporate information factory. And that's all about, bringing the raw data in to your system and then doing some curation, transformation. This is where we do integrity checks and data quality and standardization, right? Taking all those individual source systems in the staging area, and in many cases today, because of the low cost of storage, they're persistent staging areas. So we keep that raw data around for reference and for auditability. And then your next level, which is the silver level, is where you're standardizing the models, standardizing the naming, getting those agreed upon logical names of the objects and the elements to understand, again, what is a customer and customer name, customer address, all of those sorts of things. And then the gold level is where the users actually access it. And we've seen that in the corporate information factory. In the old days, it would have been staging, data warehouse, data marts. In the data vault world, it's staging, raw data vault, and then you have some refinements with the business data vault, and then you have the information delivery zone. So pretty much everybody seems to be in agreement that it's 3 tiers, one way or another. And each of those may have different models, different modeling techniques. The raw staging area is generally going to be representative of these application models. The physical models from the applications using the same structures with maybe some additional metadata. And then when you get in, it's actually almost like moving up your pyramid here, is when you're going to build the data warehouse, your logical structure for the integrated data warehouse is going to use hopefully standardized definitions, standardized names, regardless of what all the source system names are. You have to have that agreed upon. What does the business think of it? Ultimately, we're trying to deliver analytics to them. So we got to standardize on a vernacular, a taxonomy and ontology that makes sense to the business, and put that in there so that when they are trying to do business intelligence and advanced analytics and maybe even feeding into AI, that they have a model that they understand, that they're not scratching their heads going, I don't know what this is, I don't know how this is related to anything else. And so those are all going in there. And in the central zone, traditionally it was either a third normal form approach, and nowadays a lot of people, last 2 decades, people have been using the data vault approach for that core integrated historical tracking section of the data warehouse. And then on the information delivery side, or the gold layer as it's called in that medallion, a lot of people are using dimensional models, star schemas with facts and dimensions, though on some technologies it makes sense to actually denormalize everything, and you've got the one big table approach for those who like spreadsheets and just want to slice and dice in a spreadsheet. So we have a number of approaches that people use there. But you still require a model to understand this. And again, if it's done properly, you're collecting this metadata, you're collecting definitions, you're collecting relationships, so we know how these things tie to each other, ultimately improving the quality and lowering the risk of the results that are coming out of your analysis.
So it sounds to me that sort of structure and organization is vital in this sort of approach. The approach where we were saying that individual engineers would just do their own thing from sort of soups and nuts, it isn't going to work with that. So a medallion approach in your staging area or your bronze, you really need to understand the source data assets. What does each piece of data mean in there? How does that data mean in the context of standardized definitions. Your silver layer sounds like you need a well thought through, well structured design for that. And I guess the sort of the enterprise model would be a perfect resource to allow you to design that.
Yes, yeah, and back in the mid-90s, I did a book with Len Silverstein and Bill Inman called the Data Model Resource Book. And that book actually walks through, from our experience at the time, we built basically your standardized logical models for different subject areas within an organization as templates for people to look at and say, hey, does this make sense for my organization as a starting point? But in the book, we also went through and took that enterprise logical model and converted it to what at the time was, Bill Inman's primary approach, which is a third normal form data warehouse model. And then we took that and converted them into a series of dimensional star schemas for solving specific issues within the organization. So there was a progression from that enterprise logical and conceptual model to an integrated data warehouse model to a analytics, dimensional model, and making sure that was all tied together. It was all done with data model diagrams, so that people could do that. Because, like I said, that middle layer, in my mind, needs to be source system agnostic. The raw layer is definitely source system dependent because it's the raw data coming from the sources. And if you want to have any chance of auditing your results, when someone questions the results, you've got to be able to trace all the way back. And source systems change. So if you've been doing data analytics for any period of time, things on the source could change. If you don't have that stuff recorded in a persistent staging area, you've got no way to tie it back and say, well, this is why we ended up with these answers, because this is what it looked like when we received the data.
And you mentioned Data Vault earlier on. So I think we were talking the other day, Dan Lindstedt was advocating that you don't even think about Data Vault unless you've got some sort of conceptual data model.
Yeah, I mean, it's one of the first steps in the Data Vault methodology, which a lot of people don't realize there's a full methodology with it. It's not just hubs, links, and satellites, is the conversation with the business and developing a business taxonomy and ontology. And that really is, that's your starting really with your conceptual model and a business logical model. We're naming these things before you ever turn it into a data vault model and tables in a database. Is very important to start at that level. And even Bill Inman in his original writings on data warehousing talked about subject areas and doing subject area data models. And it's interesting how over the years how many people tried to do what we used to call the Big Bang approach. Is like they tried to do like the entire enterprise data warehouse all at once. And Bill always said, at a minimum, do it a subject area at a time. As we got into the agile world, we realized like subject area might even be too big, right? If we want to do an iterative approach, you don't have to model these things all at once. You don't have to model the entire thing, especially if you don't have an enterprise model. If you have an enterprise model, it's great because now you can take a piece of the enterprise model and then start refining that into your data warehouse model and into your analytics reporting models. If you don't, well, then you have to start somewhere, right? But you really need to base it on the business problems you're trying to solve and the business priorities, and not say, well, it's going to be 6 months because we don't have any models at all. It shouldn't be. You should be able to do something in certainly a couple of weeks, if not even a couple of days, depending on the area that you're looking at.
Yeah, that seems to be something that comes up a lot, sort of barriers to doing this sort of stuff. Yeah, we can't create an enterprise logical model or enterprise data model because it's going to be too big, it's going to take us too long. So I'm guessing that, as you said there, that you can just sort of focus from the top. What's the subject area that's most important to us for this organization? Let's talk about the sales subject area. And then within that, what are the key concepts that sales cares about? Well, customer, products. What are the interactions between customers and products? They place orders for them. Great. So I guess it's you sort of focus on what's important to solve the problem.
Yeah, and you do all of that before you ever start looking at a database system, right?
Yeah.
Yeah, you don't go, one of the traditional approaches that's happened in data warehousing, as you know, is people would go reverse engineer the model from one of their source systems and then try to turn that into the data warehouse model. And what that results in is what we were talking about before. Then you end up with a siloed data mart, because as soon as there's two source systems, well, now you've got to figure out, oh, we're probably going to have to change the model because there's things in that new source system that didn't exist in the first source system. And then you have to figure out how to change it, and that incurs a lot of technical debt and costs you a lot of time and money that could have been saved by having those business conversations up front before you ever looked at the source systems. If you understand the business and the business problems and the business semantics, it becomes much easier to ask intelligent questions about the raw data and about the source systems that the data is coming from. Because that's the number 3 on the list. After you define all these things, the question is okay, where do you think this data exists in your organization if we want to do analysis on it?
Yeah.
And then you have a place to start.
So next question, we've been talking about, so we've got our source data, we've reconciled that into a really nice, clean sort of structure that we can then ask questions of. The next part is the sort of the requirements. So data mesh keeps coming up again and again. So talk us through your views on sort of data mesh and data product design.
Well, yeah, the data mesh, I think, there's a lot of benefits, especially larger organizations, for data mesh, though you don't have to be a huge organization to take advantage of it. I mean, because it falls naturally along what you already have here, the subject area concept, which they call domains in data mesh. But even if you are taking a data mesh approach, you still need the models. And I've worked with a couple of large organizations that are doing this. And the challenge there was that you're giving the domain itself, the domain subject areas have the responsibility now for defining these models and responsible for data quality and sourcing the data and all of that. So the challenge there is the training and giving people a legitimate approach. So somewhere there's got to be a data modeler or data architect to help them out, whether it's somebody that is actually part of the domain team now, or is just, I'll say, an IT resource that's embedded with the domain team for a period of time to teach them how to do these things. But the models there, again, become a communication mechanism. And one of the goals in data mesh is building data products. And when you talk about a data product in that context, it's not necessarily just a data mart, but simply thinking, you could think of it as a data mart. It's a grouping of data that some consumer needs access to. And that could be internal or external, but it could also be another domain. At some point, if you're trying to build an enterprise view of the data, which every C-level executive really wants, they don't want just a view of the data from finance, and they don't want just a view of the data from sales. They're going to want to see the entire thing. So each of these domains is responsible for building these models. And again, the advantage, as we've talked already, is if you actually build these models from a business perspective and have them available, this is, I'll call it your advanced data dictionary. This is how you're going to communicate with the rest of the organization, with the other domains. What's in our data product? Yes. What's it called? What are the definitions? What are the relationships within our data product? And then that's where the enterprise model comes back in again, as you have these different data product definitions. Well, how are these data products related? And that's still a data model, right? That is still a data model. You can have the most advanced catalog in the universe, but if you don't know the relationships between these different components, you're really going to end up with data silos again, right?
Yeah. And
that's the thing we're trying to avoid. That there's somebody that's responsible for customer information, and every domain that needs access to customer information is going to pull from their customer data product. So they're not reinventing the wheel and re-engineering the extraction and transformation of that customer data. They're simply going to consume it and integrate it in with the data in their domain.
Yeah, I think that's key. So we've talked about this model on the screen. You mentioned that the domains in data mesh sort of align nicely with the subject areas in our data model. So we've got a sales subject area. So data mesh is all around sort of decentralizing data. We're going to get all the different parts of the organization that really know about the data to start crafting those data products. So great, we've got a sales subject area. Let's have a sales domain. What data products will we have in that sales domain? Okay, so we're going to have products around the sort of sales of products. Okay, so the products in that data products might come from a different domain, the product management domain. So I think this is where this model can really help, in that you understand which concepts belong to which domain, and your data products really sort of become a sort of a Lego building block exercise. The enterprise logical model is kind of your foundational data product building blocks, and the model gives you instructions on how to stick them together to form beautiful aggregate products, all standardized across the domains. Having each domain working in isolation is back to that sort of silo approach. Cool.
Yeah, and one of the rules in data mesh is interoperability. So yeah, I think the Lego scenario is great. It's like, okay, we've got this data product and this data product. Can they work? How do they connect? Is there a little overlap there? Do the little spikes line up and they can connect together nice and cleanly? And how do we manage that? And part of that again is the discoverability of the data products, as well as the ability to understand those data products and what's there and what's available.
Yes. So sounds like nothing's really changed since Ted Codd and Chris Date invented all this stuff.
No, not much. I've actually had the privilege of meeting and talking with Chris Date, or Dr. CJ Date, a number of times at some events, and actually I'm going to see him next week. He's presenting at the Worldwide Data Vault Consortium. He's doing a number of sessions on relational and temporality in relational models, which is, we don't even want to get into that. That's a whole nother topic. But last year he did an excellent talk on the 50-year history of relational, based on a book that he wrote. So it's been quite enlightening. In fact, one of his books was actually the first book that I read on relational design and relational algebra when I first started doing data modeling back in the late 80s. So yeah, the rules are still the same. The value is still the same. The importance is still the same. I argue the importance is actually even more elevated these days with the advent of things like Gen AI, machine learning, all of that.
So few people are asking in the question. So this is an obvious thing that is new since those days, AI. So how can data models help AI? Why do we need data models when we've got AI?
And it's the metadata embedded. If the AIs are going to learn, as we've seen with things like ChatGPT, it can read all kinds of information and make some, I'll say, usually logical conclusions and deductions, though occasionally we get hallucinations. If you think about trying to do things with your data, the more information about the data that's available for the AI, the smarter those answers are going to be. So everything we've been talking about, the relationships between the data objects, the definitions of those data objects. So the idea that you're just going to point an AI at a big mess of data and it's going to figure it all out, well, it might, but it's going to take a lot of compute for it to churn through terabytes, potentially petabytes of data to try to discern relationships within that data. Where if you can provide a data model that clearly delineates the rules, that, you know, this is a customer, this is how customers related to address and products and sales and orders, well, then information is now all there and can be consumed by the AI or the LLM and go from there. So I think it's even more important because the things that we are hoping to have AI do are often mission critical. And the basic rule of garbage in, garbage out still applies even with AI, right? And so the more good information, good quality information in the form of a well-documented data model we can provide, in my mind, that's going to reduce our risk greatly.
So a data model can potentially provide some guardrails to an AI to reduce the risk of hallucinations.
Exactly.
Cool. All right. And that's something very much we're looking with ER Studios. How can we, what format can we generate the knowledge in these data models to be able to give to AIs to be able to do that? Cool. So we've got some questions that are coming in. So I'm just going to run through some of these. There's an interesting one here. Are data mesh domains similar or implemented as microservices? Similar to or implemented as microservices? I mean, I guess they could be.
Yes, and I think that was in Zhamak's original articles on data mesh. That's what she proposed, is that this is effectively, this is to data what microservices were to applications. Yeah, data products, conceptually at least that way. Do they operate functionally that way? You know, there's a lot of technologies that you can use, things like data sharing inside of Snowflake, in my mind, makes that viable. All these various data marketplaces that are out there, you know, being able to expose it through a data catalog, and you being able to connect to it with a couple of clicks and then be able to integrate that data. So yes, that is the concept in data mesh.
Beautiful, yeah. Well, we're seeing a few customers asking us about this. So we want to design our data products and then realize them either as data sets in the warehouse or as sort of streaming services or APIs. But it's the same approach that you take. It's creating these logical models for each data product, and then how am I going to realize that logical model?
Yep.
And you've mentioned sort of data catalog a few times. What I didn't bring up is the next slide that sort of brings in the notion of a business glossary that
right.
sort of attaches to all of this. So a well-formed data catalog really sort of connects your physical data models to your business glossary, but you've kind of, it's two sort of unstructured worlds with the data models in the middle can really give you some sort of interesting lenses on sort of the data governance program.
Yeah.
Right, let's go through some more questions. I need my specs on for this. Yeah, do we see traditional data warehouse concepts approaches fading away with the advent of modern data architecture techniques? I think
no.
Pretty much yeah.
The concepts are all still there, and I think that's the thing, whether you call it a data lake house, a data warehouse, an analytics platform, or the data cloud. The fundamental concepts, and that's kind of the point of our entire talk here, is the fundamental concepts still apply. The technologies are changing, but your approach, your processes, those are sound, you know, based in mathematical principles. If you want to go back to Todd and Dayton, what they wrote with relational algebra, it all still applies and should be adhered to. It's, you know, we're trying to solve the same problems. We have more advanced technologies to deal with today.
Yep, cool. So here's a good one for you then, Kent. So what is the best approach for modeling for Snowflake? And I assume they mean the product Snowflake as opposed to the technique. Come on then.
Yeah, so Snowflake was designed to be, we used to say, schema agnostic. So the Snowflake engine was built for analytics, but it was built to perform equally well with dimensional models, data vault models, third normal form models, JSON, you know, JSON documents, or just, you know, big denormalized models. And it really is more about the skills of the people in your organization. I have some definite biases on how I think you should approach data warehousing, but as a product, Snowflake itself will support whatever approach that you want to take, whatever works for your organization.
Good. Okay, so in the Medallion architecture, the raw data is landed data only in bronze, refined data is in silver, and gold is the curated data. So is gold considered the data warehouse?
I think that's the entire thing. In reality, the entire thing is the data warehouse. These are just different tiers in the data warehouse. The gold curated level is, often what I refer to as information marts, or used to be called just plain data marts. That's the part that you expose to the end users, but the entire architecture is your data warehouse, where you're storing the raw data and you're storing, the integrated, historically tracked data with, doing change data capture, so you have the history. So it's all part of it. In many diagrams, you'll see really that middle tier is like the enterprise data warehouse, if you want to call it that, is in the middle, with the staging area and the reporting area on either side. But in my mind, the entire thing really is the enterprise data warehouse.
Cool. One last question, and I'm thinking this might actually be quite a big, a big topic all by itself. So, what's the differences in usage, semantics, etc., between a domain vocabulary, taxonomy, ontology, and a subject area conceptual model? So,
I don't know if we have time to answer.
Yeah, that's right. So I think, and this is an interesting one that we're looking at in the world of data modeling. So ER Studio allows you to build everything in the middle. Great, we've been doing that for 30 years. We've introduced the business glossary. Within a business glossary, you should be able to create the sort of business language, the sort of vocabulary of the business. You should be able to arrange your business terms into a beautiful ontology to help sort of find stuff and categorize and organize stuff. So you should be able to see taxonomies in your business glossary and ontologies. But then there's a whole sort of world of ontology around knowledge graphs that AIs are producing. And so there's kind of three worlds: the business glossary world, your data modeling world, and then the knowledge graph ontology. And there's lots of opportunities, I think, to sort of get those three worlds interacting and sort of contributing.
But fundamentally, they're all trying to represent the same thing. They're trying to represent the business view of the data. And that's what we're really trying to get to. And all of this, if we're ever going to get to true democratization of data science and analytics and all this AI-driven stuff, is we have to have that view at the non-technical level. And that's what we're really dealing with here. You've got the definitions and the business terminology, if you will, whether you want to call it semantics or an ontology and taxonomy, and all the relationships, so that you can understand that data in order to utilize it to your best benefit.
Yes, I think sort of business friendly is a tough one. So you could argue that, hey, the business glossary, that's for business people and business friendly, but you've got this huge sort of sea of business terms, the vocabulary of the organization, but it may or may not have any kind of structure and sort of simplification or abstraction to it. So maybe the sort of enterprise logical model with your small number of important things and that nicely structured approach can sort of be really a sort of a view for business people. We've got so many questions. I think what we'll try and do is sort of answer some of the questions offline and send this out to folks. I think this recording is going to be available online to people to go and look at later on. If you want to know more about anything we've talked about today, what we haven't really talked about is how ER Studio can support all this and do a great job. If you're interested in more, scan the little code here, get in touch with us, we can have more conversations. But I think on that, Kent, thanks very much for your time. It's been great talking to you.
You're welcome.
And I think we'll call it a day.
All right, awesome. Thanks everybody for joining.